Hello everyone, welcome to my channel. Now my name is Members Grieving and I'll be taking you through this model, my idea of Secure AI, a machine learning model that can detect suspicious behavior in a bank and trigger an alarm if there is a potential threat. So in this model, I'll be explaining to you various things and how we shall be going there. So let's start by defining what machine learning is. And it's machine learning focuses on development of algorithms and models that enable computers to learn and make predictions or decisions without being explicitly programmed. Uh, Machine learning. So in AI, in my AI that I'll be developing, it will be crucial in identifying subtle or announced behaviors associated with suspicious activities, and it will be able to act accordingly. It will also be helping in real-time analysis. It will be designed for real-time analysis of video feeds, allowing for quick detection and response to potential security threats. It also will be designed for continuous learning and improvement so that it can learn from the previous data and predict how it can use the new data to allow the system to adopt and improve its performance. So there are three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Those are the definitions, but I will explain them in the later time. So let's start with supervised learning. With supervised learning, the goal is to learn a mapping. The goal is to learn a mapping from input features to output labels. This allows the model to make prediction on a new or unseen data. The algorithm learns from examples, adjusting its parameters to minimize the difference between its predictions and true labels in the training data. For example, if let's say the model is given a data set of images with labeled categories, a cat or dog, so it's trained so that every time a picture of a dog is shown and it says a cat, it's marked wrong. So it learns from input the images it sees and what it can put. So with time, it will learn and classify new images into correct categories. It can say these are dogs, these are cats. So every time they face a picture of a cat in its input, it will be able to differentiate between the two. So when we are continuing with supervised learning, how to be applicable in the project, that will be used for classifying behavior. So here, like I told you, my project is for an AI which can detect anonymous or suspicious behavior in a bank and trigger an alarm in time. So it will be able to categorize a normal or suspicious behavior in that two. So if it's trained to that, if someone pulls out, let's say a gun, it's a suspicious behavior, it will be able to sound an alarm. So it also, supervised learning will also be able to help my project with activity recognition. It will be applied to recognize specific activities that indicate a suspicious behavior. So when you are classifying the behaviors, you still have to let the model be able to recognize the behaviors that make it to decide that this is a suspicious or a normal behavior. Supervised the types of problem I will solve. The one is classification, the way it's determined whether a specific behavior in a bank video is a normal or a suspicious. For example, classifying that a personal movement is normal or loitering. Let's say someone is loitering around. It could also cause suspicion. Why is he loitering around a bank without aim? So it should be able to classify the behavior of people. Another one is anomaly detection, which is identifying unusual or anonymous pattern behavior that deviate from the normal. These ones, it might be new, like when the video feeds and the examples that we are fed to the computer, to the AI, where what someone is doing is new, but it should be able to tell that this behavior is deviating from normal, though it was not trained to do so. It should be able to tell that the behavior is deviating from normal. So how we shall be utilizing label data? One, we have to first collect the data and label it. Yeah, we shall gather data sets of bank surveillance videos, and we'll be able to label that this is normal or this is suspicious behavior. So then we train the model using the label data set, which we have already labeled that if this is normal, if this is happening, consider it normal. If this is not happening, consider suspicious. Then we do validation and testing, where we split the data set into training, validation, and testing sets, where we use the validation set for fine-tune model parameters and evaluate the model performance of the testing set. Then there's also continuous improvement, where regular updates and retrain the model as new labeled data becomes available. So we go to unsupervised learning. So in unsupervised learning, it's a type of machine learning where the algorithm is given unlabeled data and it is tasked to find patterns and relationships or structures within the data without explicit guidance on what to look for. The goal here is often to discover the inherent structure of data, identify similarities or differences, or group data points based on certain characteristics. Example is clustering customer segments. Like, let's say a model is given is given customer-based purchasing behaviors without redefining the categories. It should be able to cluster together people who order similar things without basing on age or what they spend. It should be able to do that. So the application of unsupervised learning, it should be able to identify abnormal or unusual behavior in the bank. Here you don't feed it the previous videos, but you just train it to tell that if this is happening without the label data, it should be able to tell that this is, when you train it, it should be able to tell that this is a normal behavior or an abnormal or a suspicious behavior. So the algorithms or techniques that that I plan to use using the unsupervised learning, I will be the k-mean clustering, where I will group video sequences into clusters based on the similarity, potentially revealing patterns of behavior within each cluster. Then isolation forests, which for detecting anomalies in video sequences by isolating them from the majority of normal behaviors. So the types of patterns it should be able to learn should be usual activity patterns. Let's say it should be able to tell that if this is happening, this is a usual pattern. This is usual or unusual. It should be able to tell that the ones that deviate from typical behavior of someone who has come to bank or withdraw, open an account, or to do the legal bank activities. Should be able to tell. It should also be able to tell clustered behaviors, it should be able to discover natural groupings, which may reveal different types of normal and abnormal activities. How we shall be handling unlabeled data. One is data pre-processing. You prepare the video for unsupervised learning by normalizing, scaling, and handling missing values, ensuring that it's suitable for the chosen algorithm. Then you train the algorithm. You have to apply the algorithm to the unlabeled data to uncover patterns for itself. It should be able to uncover patterns and clusters or anomalies. So we go for reinforced learning. So this reinforced learning as a type of machine learning where an agent learns to make decisions by interacting with the environment. The agent takes actions and the environment receives feedback in form of rewards or penalties. A good example would be in a game playing. If a model is playing chess, it makes a move, and if the move is right, it gains points. If the move is wrong, it loses the points, and then it learns how to strategize, that it continues accumulating rewards over time. That is reinforced learning. And how I can use it in the project, maybe on dynamic decision making, where the agent has to dynamically adjust its surveillance to focus on the environment that matters. Maybe it could start focusing on, let's say, if it sees someone trying to penetrate to a restricted area. Yeah, if it should start focus on, it should try to make its own decisions. You can also use to in optimizing alarm triggers. It should be able to tell the conditions under which alarms are triggered and balance, avoid, between avoiding false alarms and ensuring timely response. Because if it once gives a false alarm and it loses points, it should be able to continuously develop itself so that it reduces giving false alarms to gain points. So the potential using the project, I've just explained it. So the challenges here we have the reward design on how here designing an appropriate reward system is crucial, and it's the most complicated part here, where you have to train it that if you do this, you are rewarding, you gain points or lose points. So that's the challenge that I will face. So on comparing supervised and unsupervised, in the context of the project, it is suitable for classifying labeled data feeds, labeled video feeds, and the advantage is that it's well suited for tasks with clear labels, directly addresses the problem of classifying behavior, and the challenge is it requires large and labeled data set for training. While unsupervised learning, it's effective for discovering patterns or anomalies in a video data without predefined labels. That's the advantage with unsupervised learning. So the challenge is it relies on inherent patterns in the data, which may not always align with the security concerns. So here there's scenarios where I can use supervised learning, unsupervised learning, and reinforced scenarios in my project. One, the problem statement with supervised learning would be classifying specific behavior. Here you have to label datasets containing video sequences that are categorized as either normal or suspicious behavior based on the past incidents and reviews from experts. So when how it applies, it will use the supervised learning to train the model that can classify real-time video feeds, predicting whether observed behavior align with known suspicious patterns so that it can trigger the alarm. Unsupervised learning, a scenario would be discovering anomalies in unlabeled data. So here you have a large collection of unlabeled data sequences. You just feed it to the model, and you want it to identify unusual patterns or behavior without predefined categories, without telling it that this is as a normal or a suspicious a suspicious behavior. So how it will learn techniques like it will apply learning techniques like clustering, where it can be able to cluster together feeds that are almost similar or are similar, and then you can tell it that if this happens, because it has learned itself that if this happens, this is a suspicious behavior, and it should be able to trigger an alarm. So with the reinforced learning here, the problem settlement will be dynamic decision making and optimization. Here, the security system needs to dynamically adjust itself, surveillance focus based on evolving patterns of behavior in the bank environment. Here, it should be able to focus the resources on the on moves that can help it gain points. And here, with gaining points, it will be working, and it will be working effectively. So the challenge is the challenge to face will be obtaining a sufficient amount of high quality label data for supervised learning. That will be the main challenge. And unsupervised learning may struggle if the data lacks inherent patterns, like the patterns are not flowing. So the considerations efforts are needed to ensure data collection processes are robust and that the data used for training is representative of the real world scenarios. And then another consideration is the ethical use of surveillance. Here, the deployment of surveillance systems must align with ethical standards and respect individual privacy rights. The transparency in surveillance is crucial to build trust. They shouldn't place cameras in places that are not able, that shouldn't be placed, let's say washrooms where people need their their privacy. So the conclusion with SecureEyeAI, I'll be using supervised learning and unsupervised learning. Then these are the references from where I got all the information that I put.